In continuation to the computing environments in the last video, we have client-server environment. In the client-server environment, we have two machines. The client and server communicate with each other using an external application. The server is nothing but a computer which does some particular task. The client machine sends the request to the server using an external application called HTTP. It sends a HTTP request to the server. The server responds with HTTP response to the client. Let's take an analogy. You type google.com in your browser. The server responds with google.com onto your browser. How it actually happens? The client sends a request to the server by enclosing the request www.google.com within the HTTP packets and sends it to the server, and the server responds with the page using HTTP protocol. This is called HTTP response. It's pretty simple. You request for a web page to the client, from the client to the server responds with the web page. Just remember this. It's nothing but two machines communicate using some external application. That's what a client server environment. Next, computer languages. Uh, what is a computer language? The computer language is nothing but it is a language that is used to communicate with computer. Let's take this example. A computer takes the instructions. Let's suppose you want to communicate with one person. You both know a common language, English. You can communicate with each other using this language. So you want to communicate with computer, you need a language, something like C, Java. Depending on the purpose, we use these languages. So just remember this thing. Computer language is nothing but it's a language that is used to communicate with the computer. Next, creating and running programs. The programs are created in a IDE, integrated development environment. It's nothing but it's an application that contains all the tools and editor to develop and run the application. You'll understand it better when I actually explain you the C programming language. So it's pretty generic. Understand this thing. You write the program within some application that is in IDE. Within this, you create and run your programs. Next, program development. How to develop a program? I said you this program is nothing but set of instructions. You want to ask computer to do certain task. How you can ask the computer? Using a program. How you can actually develop this program? Using a language. Programming language, you have to develop the program. Maybe C, Java. Using this, you have to develop a program and give it to the computer, and the computer gives you the response. This is what program development. You'll understand it. Again, I'm saying you'll understand it better when I actually start C programming. As a part 2 of the chapter 1 is introduction to C language. There I will explain you all these things. Next, algorithm. Algorithm is a step-by-step process to define a problem. Let's suppose you want to buy some things from groceries. First step, you go to shop, pick an item, pay money, and return. Your problem is to go to shop and buy an item. I'm defining it using a step-by-step process. How I'm actually going to do this. This is what an algorithm. See, algorithm is a very simple definition. It's nothing but step-by-step process to define a problem. Now, suppose you may have some problem like mm, something we can take an analogy like saving the electricity. First, you visit every room. Then you see whether there are any switches turned on, though there are no people in that room. 3. You turn it off. 4. You return back. This is also one type of algorithm which says about how you define the problem in a step by step way. What is a flowchart? The flowchart is nothing but pictorial representation of an algorithm. How you can actually do a pictorial representation. We have few symbols. This one is start or stop. This one is input or output, and this one is processing, and this one is a decision. Arrow is used for showing the flow, and we have a connector. Let's draw a basic flow chart. Start, then input, buy mangoes, process, you are in shop picking mangoes. Next you want to make a decision which are best. Best, yes, yes, then buy. uh, Next output, bought, stop. Here if the mangoes are not good, you come to the stop directly from here to here. You understand this thing well, right? What the flowchart, how we write this is nothing but a pictorial representation of an algorithm. We start it, buy mangoes, you are in shop picking up mangoes, and if it is the best, if these mangoes are best, you buy it, and the result is bought, and you stop it. If the mangoes are not best, you just stop there and you return back. Next we shall see most important topic of first part of first unit, number systems. What are number systems? The number system is nothing but a way to represent the number. How the numbers are actually represented within the computer. The numbers are represented within the computer as zeros and ones. As computer can understand only the machine language, zeros and ones. This is called binary number system. Generally, in our life, we use one kind of number system that's called decimal number system. That one is 0 to 9. Here we have to look at something called radix. Radix or base. It says this how many numbers are within a number system. In binary number system, there are two numbers 0 and 1 are equal to 2. In decimal, it is 10. And also we have other number system called octal. This is decimal, and here octal, that is 0 to 7, whose radix is 8, and hexadecimal, whose radix is equal to 16, 0 to 9, and after 9 we have A to F. Let's see how we can actually represent the decimal number in all of these systems and how we can actually convert them. Let's suppose how can we represent 1 in binary 0 0 1, 2 as 0 1 1, 3 1 1 0, 4 sorry it's 0 1 1, 4 it's something like let's see this 4 we can represent it as 4 to the 4 0 and some 100, yeah, 5 as 101, 6 110, 7 111. How am I actually be able to represent it? Actually the binary numbers are represented by positional values. Let's suppose if it is 001, how am I saying it as 1? We have to represent them in terms of their positional value. This is 2 power 0, this is 2 power 1, this is 2 power 2. This is equal to 0 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. That is equal to 1. This is how we are representing the number. Let's suppose I have 7. I want to convert it into binary. How can I actually do it? Repeatedly divide it by using 2. 2 3 is 6 and it's 1. Right? 2 1 is 2, it's 1. This is equal to triple 1. How can you confirm this triple 1 is 7? I said you right. Use the positional values. See, the rightmost bit is called LSB, least significant bit, and leftmost is called MSB, most significant bit. You have to start converting from the LSB. This is 2 power 0, 2 power 1, 2 power 2. This is nothing but 1 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0 is equal to 4 plus 2 plus 1 is equal to 7. This is how we can convert decimal to binary. Then after, how can we convert binary? And we have also seen this, right? Decimal to binary, and also we have seen how we can convert binary to decimal 7. Now we shall see how to convert binary to octal. What is this? See, you actually have to conceive there are octal, you know this, okay, where base equal to 8, there are 3 numbers, 0 to 7. Only these numbers are within this number system. See, take 3 elements because we are trying to convert it into octal, where these are in binary, right? It's nothing but 2 power 3 is equal to 8. So take this power, it means consider 3 elements and see this. This is 0 and 7, 5 of base 8. This is in octal number system. How you can convert? And also I said about hexadecimal. Let's see what is the hexadecimal do. Hexadecimal, we have the numbers, okay, where base equal to 16, we have 0 1 2 3 4 5 6 7 8 9 A B C D E F. There are 16 digits in this hexadecimal, and the last number within any number system is r minus 1, 15. See, here f is 15 here. Now how can we convert binary to hexadecimal? Let's see this. See, when we want to convert binary to hexadecimal, we have to convert where base of hexadecimal equal to 16. This is equal to 2 power 4. We have to consider 4 digits. This is 0 and convert it into hexadecimal. See, this is 2 power 0, right? 2 power 0, 2 power 1, 2 power 2, 2 power 3. 8 plus 4 plus 2 plus 1. 12, 14, 15. 15 is nothing but F in hexadecimal. Next 1011. So I'm just writing it. Okay, this 2 power 0 as a direct decimal. 1, 2, 4, 8 is nothing but 10, 11. 11. 11 is nothing but B. We know this, right? Okay, 0 to 11. 11 is B. Then 1, 2, 1, 2, 4, 8, 9, 10, 12. 12 is nothing but C, which is equal to FBC of 16. And how can you convert hexadecimal to binary? FBC of 16, right? See, just write it in terms of decimal first. 15, then after 11 and 12, then after write in terms of binary. You know how to actually write in terms of binary. Actually, this is we also have 0, so this is 0 0 FBC of 16. How we can convert? Okay, 0 FBC of 16. We have this thing, right? Next 15 in terms of binary. How we can actually write 15 in terms of binary? I said you this. Do the repeated division. Yeah, 0 0 0 1 2 3 4 1 0 1 1 1 1 0. This is how we convert in terms of binary from hexadecimal to binary. And you may ask the doubt, how can I convert hexadecimal to octal? Again, you know, right? Okay, octal is 8, which is equal to 2 power 3. And when it is in terms of binary, you can convert it. First of all, see this, when it is in some other number system, you somehow convert it into the binary, and from binary you take 3 digits and try to convert it into the decimal or a decimal, and see this, you can convert it into the octal as well. Okay, decimal octal, using this process. See, and you just remember this thing. Okay, binary, what is binary number system, and decimal number system, octal number system, hexadecimal number system. We have seen binary to decimal, decimal to binary. Yeah, binary to octal, and binary to hexadecimal, hexadecimal to binary. Next, hexadecimal to octal. It is not such complicated, but we can still do it. See, I said you this, hexadecimal, convert it into the decimal, then after into the binary. Take three digits, and if you take three digits, let's see this, 0 0 0 0 1 2 3 4 1 0 1 1. Next, triple 1 0. Take this. See, in terms of we're trying to convert it into the octal, so take three digits, like 3. I'm writing it again. Let's see this. We convert it from here, right? 3 3 3 again, 3 3 8 power 0, 8 power 1, 8 power 2, 16 plus 8, 24. Next, another, okay, 8 power 0, 8 power 1, 8 power 2, 16 plus 24, 25. Here it is 0 1 1. 840, 841, 842, 16 plus 8, yeah, again 24, 111, 840, 841, 842, 25. This is completely 0, 0. So okay, here we don't have extra three zeros, right? Two zeros, right? For making a three subset, like we can add two zeros in the LSB when there are no zeros for forming the octal. Yeah, 0, 0, 25, 24, 24, 8, base 8. This is how the number systems are. Okay, and you have seen this, right? Okay, binary, where its radix or base is 2. It has 0, 1, and decimal are equal to 10, 0 to 9. Next, octal you have seen r equal to 8, 0 to 7, and hexadecimal r equal to 16. This is 0 to 15. And I think this is pretty clear for you, and I hope you understand this thing better. If you get any doubts, mail me to Yashwant Chintaginjala at gmail.com. If I'm available, I'm sure I will respond to your questions. We shall see about some other topics in other video.